Well, hey everybody, this is Robert, and welcome to today's show. Now, the World Health Organization previously stated, quote, "To date, there has been no information nor evidence to suggest that the new coronavirus could be transmitted by mosquitoes," close quote. But now researchers from Kansas State University report confirming this in a new study published recently in Scientific Reports. Well, joining me today to discuss this is the Associate Vice President for Research and Director of KSUs Biosecurity Research Institute, Stephen Higgs, PhD. Dr. Higgs, welcome back to the show, sir.
Thank you very much, Robert. I appreciate the interest.
Okay, so before we talk about the research itself, right, the World Health Organization and others definitively stated that mosquitoes cannot transmit the SARS-CoV-2 virus. Now, how did they come to this conclusion without any testing?
That's a good question, Robert. So from what we know, or what is known about other coronaviruses, they were on reasonably safe ground because those other viruses are not infectious to mosquitoes and don't seem to be transmitted by mosquitoes. But to categorically state that, this virus cannot be transmitted by mosquitoes seemed very bold to me, and there are other experts. If you go on and do a search, can SARS-CoV-2 coronavirus be transmitted by mosquitoes? There are all sorts of experts out there saying, don't worry about it, it doesn't happen. But when we've seen this with things like West Nile and with chikungunya and Zika viruses, and you've certainly seen this in Florida, which I think is where you're based. A new virus doesn't necessarily do what you expect based on what its relatives do. And so I looked at this, I read this statement and heard other experts and thought, but what if? Can you guarantee just because you don't think that it will happen that it doesn't happen? And so that sort of disturbed me a little bit. Like I say, with other viruses that we've seen in the United States, things like West Nile, which came in 1999, we've known about that virus since the 1940s, and you think, oh, well, it infects these species of birds, this species of mosquito. When it came into the United States, it killed birds, which it doesn't normally do in its native Africa, and it was found in, I think, 60 different species of mosquito. So a new virus in a new environment doesn't necessarily do what you expect.
Okay, so in general, for a mosquito to be a competent vector of a virus, what characteristics must that mosquito have?
That's a great question, Robert. The answer is that we don't know some of those details. We don't know some of the most basic things about why some mosquitoes can be infected and transmit some viruses, or put it another way, why some viruses can infect and be transmitted by a particular mosquito. But there's a very tight relationship for most of these viruses that are transmitted by mosquitoes. They only infect a certain range of mosquitoes, and we don't understand that. It's a fundamental question that we would love to have the answer with. The basic biology is that those female mosquitoes are feeding on animals to get blood so that they can reproduce. So the blood is an essential food requirement to reproduce. So to be infected, a mosquito has to feed on somebody or something, an animal which has got virus in the blood. It then has to be susceptible to infection with that virus, and the virus comes in with the blood, and then if that mosquito is, as you say, competent, it has to infect cells of the gut, and then it has to escape from that gut and eventually infect the salivary glands. That can take a few days, a week or more, for that spread of the virus from the gut to the salivary glands to occur. And then when that mosquito refeeds, the virus comes out with the saliva. The saliva is a very complicated mixture of proteins which basically allow the mosquito to feed quickly, silently if you like. It opens up the blood vessels, it stops clotting so the mosquito can get in and get that blood quickly. What we don't know is if there are special receptors on a particular mosquito that allows it to be infected with that virus, and then also allows subsequent steps to get to those salivary glands and to get into the saliva. So I've been studying this since 1985, and we still don't know some of the most basic details of that relationship between particular mosquito species and particular viruses.
Let's go ahead and dive into the study, Dr. Higgs. What exactly did you and your colleagues do to confirm that the mosquito is not a vector of SARS coronavirus 2? What happened in the laboratory? What kind of testing did you do?
So normally what we do is we produce virus in cell cultures by growing the virus up, and then we mix the liquid from those cell cultures, a supernatant, with blood, and then we warm it up and we present it to mosquitoes and trick them into think that they're feeding on an animal. There's another technique, which is why the study had the word extreme in it, whereby you can actually inject the virus directly into the mosquito's body. That kind of short circuits the process, if you like. It means that the virus doesn't have to infect the midgut and get out. It goes directly into the tissues. So that's what we did, because if you can inject a virus directly into a mosquito, if it's susceptible to infection, you're going to get the virus replicating and possibly spreading to the salivary glands. And using that particular technique years ago, we were able to put viruses into things like butterflies and beetles, which of course don't blood feed, and it would multiply in the butterflies and the beetles. So our extreme approach was we took the mosquitoes, we took 3 different species of mosquito, the ones that are most commonly involved and widely distributed for transmitting viruses like dengue and yellow fever and chikungunya and Zika and West Nile. We took 3 different types of mosquito, and then we anesthetized them, which is a fancy word for us, basically putting them in a refrigerator and keeping them on ice so that they don't move. And then we injected the virus directly into the bodies. Under those circumstances, if the virus doesn't grow when you injected it directly in, it's just not going to grow if a mosquito fed on somebody that had virus in the blood. So that's why we said it was sort of an extreme test. We pushed everything to the limits in favor of the virus growing in the mosquitoes. It didn't even have to go through the blood and go through the system. We put it directly in.
Okay, well, that's pretty interesting. So the results came out is no, they are not vectors of the SARS coronavirus 2, conclusively.
That's right. Yes, they did. These mosquitoes, we injected the virus in. We checked them immediately to make sure that the virus was there in the mosquito immediately after we injected them. And then multiple times we did it we kept the mosquitoes 14 days. So we gave them the maximum amount of time that we could imagine that a virus would ever take to grow. But basically the virus disappeared in under 2 days. And that meant that under no circumstances was that virus able to infect the mosquitoes. It's one of those unusual occasions when you're hoping for a negative result, and it's good news if you get that. Not typical for research. You
Sure.
normally want positive results.
Right. So, Dr. Higgs, last question. What else are you guys doing over at KSU's BRI? What other research concerning SARS coronavirus 2 are you doing?
So, there were questions early on when this started to increase in numbers of could this virus infect other animals with which people come into contact? So we've got a researcher called Dr. Jürgen Richt. He has done experiments with pigs to see if this virus can infect livestock. And then he's done experiments with companion animals, specifically cats, because there have been cases where cats and dogs have been infected. And obviously that would be bad news if these animals could be infected and they're in people's homes and people visit. And if they were shedding that virus, it would be a possible source of infection. So they've done the studies on cats, and then they've also been performing studies on hamsters as a small animal model for the virus. Obviously, for vaccine development, ultimately it may have to be tested in non-human primates, in monkeys, and eventually in people. But having a small animal model to do those experiments is sort of an essential component of testing vaccines and diagnostics. So he's doing those studies at the moment. And then we have another researcher, Wathaka Mwangi, who is looking at vaccine development. And he's actually got a contract with a company to develop new vaccine platforms. So it's a busy place for SARS-CoV-2 research at the moment here.
Very good. And it was a very interesting study, and I'll go ahead and link to that in the show notes when I publish the podcast. And I want to thank you, Dr. Stephen Higgs, for sharing your time and your expertise, sir. Thank you so much.
Thank you very much, Robert. It's a pleasure.
All right. Have a great day.